Imagine this, your music, your voice, stolen by an AI. Then, you get hit with copyright claims, losing revenue, all because an AI mimicked your work so perfectly it was indistinguishable. That's not a hypothetical. It's already devastating real artists, and it's happening right now. Yet, the same technology generates over 60,000 songs daily, with a stunning 34% of all Spotify uploads now AI-driven. We've seen AI bands like Neon Oni amass over 80,000 monthly listeners and 1.2 million streams for their top track, only to then transition into a real human band with 7 musicians performing those AI-generated tracks live. Zaniah Monet, an R&B artist prompted by Nicky Jones, even secured a multi-billion-dollar record deal. It's a paradox, boundless creativity coexisting with brutal infringement, blurring the lines of original artistry. But this isn't just about music. AI's impact is reaching everywhere, often with equally profound and unexpected outcomes. We saw Chinese robots, named Lightning, not just compete, but win a half marathon, shattering the human world record by 6 minutes. AI video generation is hitting new realism, exemplified by Marco Slavnik's viral short using Cants 2, which racked up 5 million views in a single day, sparking serious questions about animation's future and training data ethics. In medicine, there's the extraordinary case of a man using ChatGPT and AlphaFold to design a personalized cancer vaccine for his dog, leading to significant tumor reduction. It asks potent questions about AI's potential in human health. But then, the blunt reality of Clearview AI's surveillance, which wrongly identified a grandmother, leading to her arrest at gunpoint and 6 months of imprisonment. The spectrum of AI's reach is breathtakingly wide. None of this astounding innovation, from generative AI to advanced robotics, would even be remotely possible without an equally sophisticated, yet almost entirely invisible, foundation, the operating system. Think about it. From 1956's GM Neo, the very first OS, which incredibly crashed less than Windows Millennium, to modern systems like Mac OS, Windows, or Linux managing hundreds of programs concurrently. The evolution is staggering. Our CPUs operate with privilege rings, where ring 0 houses the kernel, and ring 3 is for user space. This isn't just a software convention. It's a critical separation enforced by the CPU itself. The kernel constructs virtual memory, intricately using page tables and the memory management unit, handling memory in precise 4 kilobyte pages. This gives each application its own isolated address space, a crucial layer of protection. Beyond memory, disk storage is meticulously organized by file systems like ext4, NTFS, and APFS. They use journaling to prevent data corruption, especially during unexpected power loss. And those crucial device drivers? Their specialized code, operating in kernel mode, translating generic requests into hardware-specific instructions. A single buggy driver, one tiny flaw, can crash the entire operating system, bringing everything to a halt. Hardware events trigger interrupts, electrical signals that instantly yank the CPU to execute a specific handler. PID1, often Systemd on Linux, is the ancestor process for all user space applications. If it fails, you get a kernel panic. System calls are the secure gateway, transitioning the CPU from user to kernel space for privileged operations. All while the scheduler, a silent orchestrator, expertly manages hundreds of processes across limited CPU cores. Threads within programs enable parallel execution, but they introduce the risk of race conditions, where timing issues can corrupt data. This intricate, underlying machinery, though largely unseen, is the bedrock enabling the dizzying pace of AI advancement we're witnessing. It's a world where groundbreaking capability and inherent fragility coexist at the bleeding edge. The full picture isn't clear yet, but these numbers don't lie. 34% of Spotify uploads are AI-generated, and growing.